Okay, today we're looking at section 7.4, which is division properties of exponents. Hopefully by the end of this lesson you can say that I can divide with the same base and I can raise a quotient to a power. So first of all, I can divide with the same base. So if we take a look at these two examples, we can kind of get an idea of what this means. So if I looked at a to the sixth divided by a to the second, so all I'm going to do, I'm going to expand this out to what it really means. So a to the sixth really means a times a times a times a times a times a divided by a times a. So if we do that, hopefully we can see that we got things that cancel out. The a's here cancel out, these a's here cancel out. So what are we really left with? We're really left with a to the fourth. So if we look at the bottom one, now I've got m times m on top, and on bottom I've got an m times an m times an m times an m times an m. Okay, so again, we can see that things cancel out. And what are we left with? This time we're left with a 1 over m squared. So how can I put this into words? What's happening here? So in my thought process, I simply look to see where I have more of the same base. So for instance, in this first one, I have more A's on top. And if I think about how many more, I would have 4 more A's on top. So therefore, I have a to the fourth in the end. Okay. The second one, where do I have more M's? Well, I have 2 more M's on the bottom. Therefore, after things are canceled out, I'm simply left with m to the second on the bottom. Okay, so that's our first rule. The other way that you can look at it is simply that we're subtracting exponents. So a 6 minus 2 does give us the 4. If I look at it this way, 3 minus 5, that's an m to the negative 2 then. However, if we rewrote it, that would be still just 1 over m squared. Okay, so I just prefer, to me it's simpler, just to think about where I have more m's at or where I have more a's at and how do they cancel out. Okay, so the next one we're going to look at is I can raise a quotient to a power. So first of all, what is a quotient? Quotient is like a fraction. So for instance, in this first one, this is really 2/5 times 2/5 times 2/5. So what do I end up with here? Well, essentially I have 2 to the third over 5 to the third. And we are going to go farther with that, but so this would be 8. 2 times 2 times 2 is 8. And on bottom I get 125. So, but what I want us to focus on is this right here before I do my final simplification. And again, this is very similar to what we did with anything in parentheses. Everything in it gets raised to that power. So this 3 doesn't only apply to the 2, but that exponent also applies to the 5. Okay, so if I look at the second one, here I'd have m to the second over n to the fourth times m to the second over n to the fourth times m to the second over n to the fourth times m to the second over n to the fourth. And I got one more of those. M to the second over n to the fourth. So what do I get? Well, on top, I have m to the 10th. And on bottom, I've got n to the 20th. So what would be an easy way to remember this? Again, this exponent applies to everything. So what do I do with these two exponents? A power of a power. I'd be multiplying those two. That's how I get 10. Likewise, down here, the 5 and the 4, that is how I got the 20. 5 times 4 is 20. So my final result would be m to the 10th over n to the 20th. Okay. So now, let's look at some examples. So this first one is simply kind of laid out like we had talked about it before. So we expand it out, and we would get 3's canceling out. So I'm left with simply 3 to the third. Well, 3 to the third is really 27. So I'd simplify that to 27. Okay, this next one. Where do I have more 6's? Well, I have more on top. How many more do I have? I've got 4. So I've got 6 to the fourth. And then if I wanted to use a calculator to calculate what 6 to the fourth really is, That's 1,296 would be my final answer. Okay, let's look at this next one. So again, I asked myself, where do I have more y's at? Well, I have more y's on top, and how many more do I have? I've got 3. So I'm simply left with y to the third. Likewise on number 4, where do I have more m's? I have more on top. How many more do I have? I've got 3 more, so I've got m to the third. Okay, hopefully this is making sense to us. So now if we looked at these two, I just want to give you a little bit of time. You try and figure out what you would have. Okay, so the first one, if you look at the x's first, there's obviously more x's on top, and there would be 4 more x's on top, so I'd have x to the fourth. The y's, I got 4 more y's than I do on the bottom, so I'd have y to the fourth. And nothing would be left on the bottom, so I'd just leave it like that. Okay, this next one, I've got a 21 over 3. That simplifies, first of all, to a 7. And then we got to think about these m's. Before we talked about where do I have more of them at. One way to think about it, I got 1.5 on top. That's 3 over 2. So I have 1 more on top. So it'd just be simply an m left. Okay. So here's the same idea we were talking about before with the power, or yes, the power of a quotient. So we expand it out. We get 2 to the fourth over 28, and 2 to the fourth is 16. So I'd have a 16. 7 to the fourth is 2,401. So I'd have 16 over 2,401. Okay, if we think about this one, this is really going to be 3 to the third over 2 to the third, not second, and 3 to the third, excuse me, is 27. 2 to the third is 8, so I'd have 27 over an 8. Okay, so I'll give you a little time to think through these and see if you can come up with some answers on these. Okay, so the first one, we should have been thinking that everything in there is going to get squared. So I'd have a 5 squared x squared over 3 squared y squared. So I'd have 25x squared over 9y squared. Okay, and this next one, everything is going to be raised to the third power. So I'd have 3 to the third, and now I've got x now to the 12th, and then I'd have 2 to the third, and I'd have y to the 9th. So final step, 3 to the third is 27, so I have 27x to the 12th over 8y to the 9th. Okay, number 11, hopefully we could have seen a little bit of a shortcut. And remember that anything to the 0 power is simply 1. So this is simply 1. Okay, and then this next one, a couple ways you can approach it. One way would be to simplify first inside of the brackets. So let's try that way first. And see, where do I have more x's? Well, hopefully we can see that we have 2 more x's on the bottom. So I'd have x to the second on the bottom. The y's, however, there's more y's on the top, and there's 2 more on top. So I'd have y to the second on top. And then when I take that all to the second power, that would simply become y to the fourth over x to the fourth would be my final answer. Okay, hopefully we're doing all right here. So now, another example, a little bit different twist on it. So first of all, we've got 4 to the negative 2 on top and 7 to the negative 2 on bottom. Oh, excuse me. So how can I deal with that? Well, I can just flip it around. And I would have 4 to the second on the bottom, 7 to the second on top. So that becomes 49 over 16. How else could I have thought about it? Well, the other way that I sometimes think about these is when I have a fraction to a negative exponent. I think about that as simply the reciprocal to the positive exponent. So you could have done it that way, and you would have gotten, again, 49 over 16 when you square both of those. Okay, so if we look at number 10, a couple ways you can look at it. Again, you can flip it right away. So that would be a negative still, y, or 2y to the fifth on top now. and 3x to the fourth on the bottom. And then that's all to the positive 3 power. So then I've got a negative cubed is still a negative. So my answer is going to be a negative. 2 to the third on top, y to the 15th, over a 27, or a 3 to the third, first of all, x to the 12th. So my final step, I've got a negative 2 to the third is 8 y to the 15th over 27 x to the 12th. Okay, one final slide here. Let's take a look at these two and let's see what we can do. So first of all, what would I do? Well, we can simplify inside of the parentheses, might be the best option. So inside of the parentheses, if I simplify there, I would have, you can divide each of these by 3, the 12 and the 15 reduced by 3, so I'd have 4 over a 5. Okay, p to the 3 halves over a p. Where do I have more p's at? Well, I have more on top, and I have a half left if I canceled out one of them. So now I got a 4 p to the 1 half over 5, all to the 4th power. So now everything in there gets raised to the 4th power. So I got 4 to the 4th, and then p to the half to the 4th. If we multiply those, we'd simply get p squared over 5 to the 4th. Now you use your calculator, and you know that 4 to the 4th is 256. So 256 p to the 2nd over 5 to the 4th, which is 625. Okay, now the last one. First thing I would do, I'd simplify inside. So my a's, I know I got a to the 4th on the bottom. I know I got b to the 2nd on top. And then, next thing I do, I think about the reciprocal idea. Okay, so now I've got a to the 4th over b to the 2nd, all to the positive 2. And then I simply carry out the last thing. So then I'd have a to the 8th and b to the 4th. Okay, so I know this is a lot that I just covered, but hopefully you can ask questions of someone. If it's not me, maybe a neighbor. And that, my friends, is a wrap.